Hey guys, this is Einar. I hope you're doing great today and welcome to your second theoretical tutorial in this course in Basic Statistics 1 at the Stockholm University. Now this tutorial we're going to talk about variance and the standard deviations, which are two very important measures in the social sciences because they concern the uncertainty of guessing the values of different variables using samples. Before we start talking about that, I'm going to talk about some maths with you because this is something that confused me when I was studying statistics for the first time. So I figured I'm going to talk about this just to make it really clear for you. You see these i's here equal to 1, I, and n, and you can see the i's here in each observation. What they represent is the index of each observation, and in this case I placed them on the x-axis. So what we're doing is we're going through our material and each observation gets a number. We start at the smallest and we continue forward. Now we're not sorting them from smallest age to largest age. We're actually indexing them from, in this case, the order in which they appear in a data set. That could be the order we registered the ages, for example. Now, why am I telling you this? Well, because it's used in this formula where we are summing up something. Now when you use this sum sign here, it tells you that we start at I equals to 1. So we started our first observation. Then we do this, which in this case is going to be subtracting the mean from each observation. And then we continue doing this for each observation till we reach n, which is going to be a number. And in this case, n is actually the same as our total population, but it doesn't have to be. N could have been equal to 8 or something if we only wanted to do it with the first 8 observations. So that's just important to realize that the n is how far we're going and I is where we're starting. And then we're doing this for every observation. We're doing it all over and over and over again, and then we're summing up the results of this operation to a total number. So that's what we're doing with the sum sign, and that's what these i's mean. So this, for example, is I equals to 1. It's the first observation. This would be I equals to 2, the second observation, and so forth. So let's take a look at our formula. What kind of variation are we talking about? Well, if you have something that varies, it has to vary in relation to something. And in this case, we're talking about variation around a mean. Now, what is a mean? Well, the mean is, it takes all the values of these into account, and it divides by n. That's the mean, or in common terms, the average. So it is going to be placed in the center of our data set. It's a measure of centrality. And in this case, you could say that that center is the best guess of the age that represents this data set the best. So if I was to pick a random person out of this material, I would say that the mean is the best guess, and to guess the rates. But the problem is that none of these people actually have the age 36.6. It's a theoretical measure, and also they vary quite a lot. This person is probably like around 79 years old, and this one is like 13 or 12 or something. So they all vary around this measure, which we call the mean. We have to deal with this variation somehow, because this variation will in turn vary. Sometimes in some social phenomena you will have a lot of variation, and sometimes you will not. You will have very little variation. It all depends on what questions you're asking. What am I interested in studying? I will always have variation in every social phenomenon that I encounter. I will have variation in the incomes of different people. I will have variation in their political views, and etc. So if we're going to guess something using statistics based on a sample, we have to make sure we take this variation into account. And that's what variance is all about. So its first component is going to be a measure of centrality, because that's what we're varying around. And what we're going to do is we're going to subtract this measure from each observation. And when we do that, we get a distance. And this is actually a distance measured in years. So this person here, who's 79, is a number of years away from 36.6 years old, above average. This person is below average, and they're a number of years below the average. So what we're doing is we're taking each observation and we're subtracting their distance from the mean, and then we're adding them all up. But there is a problem here that we have to deal with. Each person's distance is going to be either positive or negative. If you're below the mean, this distance will be a negative number, because the mean in this case is going to be higher than their value for the y-axis, which in this case is age. So you won't get a number that makes any sense. You won't get the summed up distance, because that's what we're looking for. We want to sum up all the distances like we're doing here. We want this distance right here, all summed up, so we can divide it by n, split into equal parts, and we get the best guess, so to speak, for the distance we mean. But the problem is, when we take all of these negative numbers and all of these positive numbers, they're going to equal 0. And that's a big problem, because if we take 0 and divide it by this n minus 1, we're going to get 0, and no matter what these observations look like. And the reason for this is that the average, or the mean, as we have been talking about, is a measure of centrality. So it's the nature of the mean is to be in the center of the material. So when you add up all the distances to this mean, it's going to equal 0. How do we solve this? We need to solve this in some way, otherwise our formula is useless. And one way of doing this is using a mathematical fact that if you subtract a negative number by itself, you get a positive number. So that's what this number 2 here is all about. You take the distance and then you multiply it by itself before adding them all together, and then you make sure that you get a positive distance. You then divide this by n minus 1, and you get a measure we call the variance. So you see each distance here is raised by 2. So the distance around this mean is raised by 2. The problem with this, however, is that it's not a very intuitive measure. The fact that we're raising it by 2 gives us a much larger distance than measured in age. So the scale here is changed, and it's difficult to explain to people. It's difficult to grasp. It doesn't make intuitive sense to raise everything by 2. We somehow have to deal with this if we're going to deal with it in a final measure. Now, there are other statistical uses of the variance, so it still has some uses, but for now, don't think about that for now. Think about the fact that we have to deal with the fact that everything is raised by 2 here. Well, if you take a negative number and you raise it by 2, you get a positive number. But the problem is this positive number is a lot larger than this number, right? Well, if you take a number and you square root it, you go back to the 2. So if you raise something by 2 and then square root it, you go back to the original number. But notice that the sign now has changed. So while it was negative here, it's positive here. So what we need to do is we need to draw the square roots of our observation. And incidentally, that is called the standard deviation. So when we draw the square root out of our formula, we're actually getting the actual distance from the mean here. And that's amazing, because that's what we've been looking for all the time. Now we actually have the summed up distance from the mean. And that allows us to divide this by n minus 1. And when we divide it by n minus 1, we're getting the average distance to the mean. Or in other words, you're getting the mean distance to the mean. So it's sort of like our way of saying, like, we're guessing that if we were to guess a person's age in this material, we would say 36.6. And the variation around the material is on an average this far from the mean. And that measure, the standard deviation, is a really good measure of how good our guess is, because that tells us, how much variation in general is there around our guess. So the standard deviation is a very useful measure. It's used all over in the statistics, and we will be making good use of it in the future tutorials that are coming up. So take good care. Try to learn this. Try to grasp it theoretically. It can be difficult. It took me a while to learn, but it's amazing when you realize all the great uses you have for this measure. So I wish you good luck. Have a great day, and have some fun playing around with this formula in the tutorials that we're going through. So good luck, and I see you later.